In this video, we'll take a look at ratio and proportion in sections 18.1. So ratio is a quotient of a to b. So anytime you work with fractions, such as a divided by b, it's a ratio. A fraction with the same units, such as 23 feet to 13 feet, is a ratio where the units cancel out, resulting in 23 over 13. A rate is a ratio as well, but it compares two different quantities, two different units. So for example, 32 miles over 1 gallon, the ratio, is called a rate because the units are different, and that means 32 miles per gallon. Another example, 360 revolutions in 15 seconds means 360 revolutions per every 15 seconds. So where do we use ratios and rates? Well, a ratio, another place we use it is a percentage. Percentages are a ratio of a value to 100. So 35% means 35 per 100, which is written as a fraction, 35 over 100, or as a decimal. The 35 over 100 is the ratio. Rates are used to represent measurement conversions. So if you're converting from inches to feet or feet to inches, we use something called a unit fraction, or a unit rate, where 12 inches over 1 foot, or you could write it 1 foot over 12 inches, and that's called a unit rate because it reduces to 1. 12 inches and 1 foot represent the same measurement. All right, so let's take a look at some examples that you'll see in homework of ratios. The first example says the specific gravity of a substance is the ratio of its density to the density of water. So I'm going to write down that ratio. It's the ratio of its density of the substance to the density of water. Okay, if the density of a steel alloy, so that's our substance, is 455, I'm going to write 455 pounds per cubic feet, so that's the unit of measure, and that of water is 62.4 pounds per cubic feet. What is the specific gravity of the steel alloy? So we write it as a ratio, 455 pounds per cubic foot divided by 62.4 pounds per cubic foot. Since the ratios, the measurements are the same, the ratio is 455 to 62.4. It says to round that to 2 decimal places, so we put it in the calculator. We end up with 7.29166. We want to round to 2 decimal places, so that's 7.29. We don't round up because the number after the 9 is a 1. All right, next example. The percent error in a measurement is the ratio of the error in the measurement. So it's a ratio of the error in the measurement to the measurement itself. It's expressed as a percent. So when writing a computer program, the memory remaining is determined as 2,580 bytes, and then it's correctly found to be 2,660 bytes. What is the percent error in the first reading? So the actual measurement is 2,660, but we had an error. We measured it as 2,580. So we need to express the numerator as the error. So the error is the difference between the two. 2,660 minus 2,580. So the error in our measurement is 80. The ratio of the error to what it should have been is 80 divided by 2,660, which is approximately 0.030075. It says the percent error, so we want to make sure this is a decimal. We want to change that to a percent, and round it to 1 decimal place. So we have to move the decimal places 2 to the right first. Okay, so that's 3/100ths. And then to round to the nearest percent, that would be 3.0075%. To round to 1 decimal place, the value to the right of 0 is 0, so we end up with an error of approximately 3% or 3.0%. All right, so that's a review of ratios and rates and how to take a look at problems that deal with ratios. Well, the next part of this notes is a proportion, and a proportion is a statement that two ratios are equal to each other. So if you have A over B equals C over D, that's a proportion. So remember when you're reducing fractions all those years ago, you reduce 3/9 is the same as 1/3. Okay, you were writing that's a proportion when you write them down this way. A unique value or a unique property of proportions is if you cross multiply opposite numerators and denominators, they'll be equal. 9 times 1 equals 3 times 3. Let's try that again with a different true proportion. We know that 2/3 is equal to, if I multiply each by 2, 4 over 6. That's a true statement. If you cross multiply, 3 times 4 is equal to 2 times 6. So that's a property we're going to use when we start to take a look at solving problems that have to do with proportions. Okay. Our first example of where proportions are used is a scale of a map. So anytime you're reading a physical map or blueprints, they put a scale on there. So on a certain map, 1 inch represents 31 miles, which means that we have a ratio of distances of 1 inch to 31 miles. Also on this map, Cooperstown, New York, home of the Baseball Hall of Fame, is 11.5 inches from Canton, Ohio, home of the Football Hall of Fame. Therefore, to find the distance from Cooperstown to Canton, we can set up a proportion. So we set up what we know, map distance to land distance on the map is 1 inch to 31 miles. And then we set up the map distance, 11.5 inches, to x. So that's setting up a proportion. If we want to solve and find x, what we would do is we would cross multiply. X times 1 is 1x equals 11.5 times 31. And those two values multiplied together, and it would be in units would be in miles. 11.5 times 31, 356.5 miles. Next example, changing units of measurement. So whenever you're doing unit conversions, you can set up a proportion. In this example, we're given that 1 inch is equal to 2.54 centimeters. And we want to know what is the length in centimeters of the diagonal of a flat computer screen that's 17 inches long. All right, so we're going to set up a ratio using the measurement. So I know that, and it doesn't matter which way you go, 1 inch equals 2.54 centimeters, or I'm going to write it over here, 2.54 centimeters over 1 inch. The only thing you have to make sure is when you set up the other proportion that you have inches in the numerator, centimeters in the denominator. So what is the length in centimeters of the diagonal of a flat computer screen that's 17 inches long? So I have to make sure I have the 17 in the numerator, and I'm looking for the length in centimeters. If I set up my original proportion the other way, or the original ratio, then I would have x centimeters in the numerator and 17 inches in the denominator. Okay? So when you solve, cross multiply. 1 times x is x equals 2.54 times 17. And this is how the answer of the 43.2, that's where that came from. and our measurements would be in centimeters. All right, so let's take a look at a couple of problems, or one problem from MyMathLab. In testing for quality control, it was found that 16 of every 454 computer chips produced by a company in a day were defective. If a total of 496 defective parts were found, what was the total number of chips produced that day? So we want to make a ratio of what we know. We know that 16 of every 454 were defective, okay? So what we want to have is a ratio of defective to total. We have 16 defective out of 454 total. We're going to set up a proportion. We are given the number of defective parts. So that goes in the numerator. What was the total number of chips that day? X goes in the denominator. So setting up your proportion, you have to decide how you're going to have your ratio, defective to total, and make sure that both of your ratios on either side of the equal sign are set up the same way. Then I'm going to go ahead and cross multiply. I'll take 16 times x is equal to 454 times 496. That leaves me 16x equals 225,184. Divide both sides by 16. We get 14,074. So that's how many chips were produced that day. 496 were defective, and then 454 the previous, a different day, was 16 defective. It's in the same proportion.